Well, good evening, everybody, and welcome to another Tech Talk Thursday night. As always, I hope you're having a fantastic morning, afternoon, evening, night, depending on your time zone and sleep schedule, as always. Speaking of sleep schedule, he is awake. Say hi, PXLib.
Evening, everybody.
And we do have audio, which is always an adventure with our setup.
Seems like it. We'll get it down eventually.
All right. So we're going to have a pretty chill stream tonight. We've got a couple of things that sort of came up in the wake of our some previous streams and in the wake of stuff I was doing, and some of these things are only very loosely connected, but I think they're all fun, and like I said, it'll be super chill, and hopefully interesting. One bit of housekeeping. It turns out that you can throw a couple of bucks at Twitch and they will store VODs for the same amount of time that they do for affiliates. So I did that, and so I'm happy to announce that our VODs now stick around for whatever, 60 days or whatever the amount of time is that they would for affiliates. So that means that you'll be able to you can just go to Twitch and catch a replay of the VODs. I will still put things up on YouTube, but it puts a little bit less pressure on me to get that done quickly. And in some ways, it's just kind of a little bit easier to have it all in one place. All right. So the first thing that came up, again, sort of in the wake of, this was really in the wake of last week's stream. So just as a reminder, we were working with different video formats, and using ffprobe to pull data about the individual frames. And so let me bring this one up here. I think I can do it this way. Now, does this one have a... No, it won't do it that way. So let's see. Can I zoom? Oh, so I'm supposed to be able to do it this. There we go. No? Yes? Maybe? No, that's scrolling. All right. How do I zoom? Control plus. Oh, okay. Oh, okay. Or I supposedly can do. There we go. Right. So. Every one of these programs uses a different methodology for zooming in and out. It's not important that you can read this on screen. It's just I just want to make it large enough to sort of see the gist, right? So this is a comma delimited file that there were a couple of pieces of information in here, like the fact that each frame is 1/30th of a second long, and then right here are the sizes of each frame, right? And then what we ended up doing is we went here and basically pressed Excel into service to give us and this is only a small portion of the file, to basically to analyze the file and give us kind of a graph showing. And the spikes obviously are the iframes where the video files need significant additional bandwidth momentarily. So after stream between that stream and today, we've been sort of talking about this isn't really a good way to do this analysis. Excel, I love Excel. Excel is probably one of the best products Microsoft has ever put out. Short of maybe VS Code now. I don't know. If VS Code
I'd certainly lean VS Code.
May vote for that. But yeah. Excel is one of the best products Microsoft has put out. I think has ever put out. So I love Excel, and it's very useful for lots of things. Analyzing really large data sets isn't one of them. We ran 2 minutes worth of video, 33,000 odd frames in this sample. And while it's perfectly doable, it's just when you're scrolling through thousands and thousands of lines, it's just not a very comfortable place to work for this type of data set. It can be done, absolutely can be done, but it wouldn't be my first choice for doing this, especially not if I had to do this over and over again for, here are 10 video files, go analyze them. I'm not sure I want to do it that way. And so we had that kind of this conversation about how we would do this better. And so let me minimize this guy. So my old school approach is I kind of like best in class, individual kinds of things. And so my conclusion was I don't mind running ffprobe, which we've already done, and it's pretty easy to do. It produces this comma delimited file, and now I've got to plot it. I've got to graph it. I can't remember the name of it. On Mac OS, which is one of the operating systems I've used for years and years, I'm not using it very much right now, but I've used it for a long time. I actually went to the Mac App Store and bought a scientific graphing package. And I've used it, not recently, but I've used it for years for various. So basically, you just import a data file into and then you can create really complex and well-formatted graphs. So, unfortunately, there really isn't anything equivalent that I found that I really liked. There are a couple of options. There's one option. It's actually an online graphing package. There are quite a few graphing packages, but they're not free. And while I didn't mind paying $50 for the thing I got on the Mac, the lowest cost I found is something like a $500 or $1,500 a seat license, which, God, you've got to have you've got it running like a pharmaceutical company or something to really want to pay that sort of licensing for a basically scientific graphing package. So again, there are other options, right? But in this case, actually, in some ways, it was sort of serendipitous. I said I wanted to mess with this for a while, anyways, and so I ended up looking up a package called Gnuplot. There it is. And it has a very 1980s looking homepage. Enlarge this a bit. But it is free. It has a ton of something should give away just how long this has been around. Here's a quiz. What is OS 2? Do you remember?
I know, but I can guess. Or I have some guesses. I would be curious to know for certain.
OS 2 is a PC operating system. It's a competitor for Microsoft Windows.
Yeah.
I think it was an IBM product, if I'm not mistaken.
Right. Yep.
I actually used it for about 2 years. We were experimenting with it at the company I was working with at the time, so it would have been in the late 80s. We were experimenting with using it as a platform for the software we were distributing. It never went anywhere. But yes, so this goes way back, and in fact they have a date here. So they've been in development since 1986, which would make sense because that was the heyday of OS 2. So, and it is super cross-platform. In fact, VMS is the old digital equipment operating system. I'm pretty sure. That's a VAX operating system.
That vaguely rings a bell.
So yeah, which again, that was a mini computer in widespread. That was in wide use. In the 80s. I did my dissertation work in the late 70s on a digital equipment DEC 10, but I did a lot of my postdoc work on PDP-11s, digital equipment PDP-11s running VAX VMS, and then when I was working commercial in a commercial software house in the 80s, that's what we used for development. So yeah, so this stuff's been around for ages. So there's some good things about this and some bad things about this as far as I only poked at a little bit. So it is at heart a Linux and Unix, Linux style application. I have no idea what they did on OS2, and I don't care. Same thing for the VAX, VMS. I have not run it on Mac OS. I'm actually really curious to do that sometime this week to see how it runs there. So and I think this is kind of interesting to hi ODG, well, welcome. Can we do a shout out for ODG? He's a British retired IT person, and has a lovely stream. It's a stream that is at least in part dedicated to dealing with depression, but the stream, it's in and of itself, is a ton of fun, and it's a mix of gaming and IT and just tinkering with stuff. So welcome. It's good to see you. Yeah. So let me grab my tablet here so I can draw on my whiteboard. I should mention I started teaching last week, and of course in this age of the plague, I'm teaching remotely, and God, I don't like it. Give me a whiteboard, even an electronic one, and let me just kind of do stuff. But yeah, ODG said you had to try and get in early so you have some idea what's going on. We're so glad to have you. And before you stopped in, I pointed out that if you throw a couple bucks at Twitch, they will keep your VODs around longer. So I've done that. So there's not as my VODs will now stick around as long as the same amount of time as the VODs for an affiliate. So they won't go away quite as quickly, which I think might help you. I know you've enjoyed kind of going back and rewatching them. So what we started talking about is, remember last week we ended up with kind of a large data set looking at the individual frame data for video, and I was messing with Excel to try to sort of visualize what that looks like, and it's obviously not quite the right tool, and so we were looking at what options do we have, and one of the sort of weird issues, and I think this is kind of what Pierre Slip and I were talking about during the week. So you have kind of a weird issue that didn't used to be an issue, but it has become one because of the changes in maybe it just says it was only 2 weeks as affiliate. So as a non-affiliate, I know it's 2 weeks. So maybe it's the same as partner, but they're basically, I think it's 60 days now that I've paid the piper. What Excel does when we talk about visualizing information, in this case we're trying to draw these graphs, right? I mean, I've got the so I have my operating system that provides a set of services. right? And among them is essentially a graphics engine, which the operating system uses obviously to do what I'm doing now, right? So each of the operating systems certainly has an intrinsic ability to provide graphic support. The question is, how do you get at it, right? And so you have a program like Excel, and pxlib jump in anytime I get this, screw this up. But if you have a program like Excel, this is a native program, right? So it's written on top of the operating system. Thinking back to my days as a somewhat, I never wrote software that was close to the operating system, but I did have to do some debugging work on it. And eventually, some modern C software, C++ software, basically makes a whole bunch of operating system calls to get services from the operating system. And one of the things that I can do is I can ask the operating system to open a window and create a canvas and draw on it, and all that good stuff. So for the folks that build Excel, this is kind of straightforward. Well, maybe not straightforward, but so conceptually, it's kind of easy to figure out. If you're writing Excel, you sort of know what you need to do, and you're already obviously using the graphics capabilities of the operating system for all the other stuff you're doing. So the question we were stuck with is I've got a data file, and so now I need something to visualize it, right? And so Gnuplot creates that glue in some ways. Whoops. That was supposed to be an N. So Gnuplot sort of works the same way as Excel does, right? In that it can use the operating system to access data that's stored in a file, and it can use the operating system to access the graphics planes, and so it can do drawing. What makes Gnuplot kind of interesting is the fact that it's cross-platform, which is sort of good and bad, right? So I think it lives nowadays on Linux, so that's its native environment. I said I'm kind of curious how it runs on Mac OS, and I have not played around with that. I said I don't care about OS 2. So ODG, here's a question for you if you're not off getting a drink or a snack. Do you remember OS 2? Because Gnuplot apparently started right about the time that OS 2 was. Gnuplot was started right about the time that OS 2 was in its heyday. I remember it badly. Yeah, I worked with it for about a year or so. We were trying to figure out if it was a good platform for the software I was in charge of. It wasn't, in part because they never had driver support for half the devices attached to the PC that we were running on, that sort of thing. So it never really went anywhere. So Gnuplot really is a Linux. Gnuplot is really Linux based. OS 2 was mid to late 80s. OS 2 was an IBM operating system introduced in the late 80s. And I think it just fizzled after just a few years. It had kind of a small dedicated following, as these things are wont to do, but never really went very far. I mean, basically, Windows got better. What happened is Windows got better, and there was no reason for people to mess with another operating system. Also, Mac OS came along. That is right. It was right before Windows 95. So Windows 95 came along. Mac OS had come out right about the same time, and it just got squeezed out because there were other more established and better options. Yeah, you installed it once, took about 2 hours before it got uninstalled. Yeah, we spent a lot longer because, in theory, it would have been fairly beneficial for us, but we never decided to use it either. So, Yeah, OS2 was not a bad operating system. The real problem was that the hardware support wasn't there, and so we could never get all the stuff we needed to work properly because the drivers weren't there. So the reason for this long discourse here is that Gnuplot is going to natively want to use the X Windows services that are typical on Linux and Unix. I have no idea how it links to the Mac OS graphics plane, but because the Mac OS kernel is a Unix kernel, it's a lot easier there. So the first thing I noticed is when I installed this on Windows, which I did. Gnuplot on Windows actually uses a shim. There's a project called MinGW, which is essentially it's basically a precursor of the Linux subsystem for Windows.
Yeah, that's a good description of it. It's also the bane of every cross-platform developer.
There are a couple of them. MinGW is the most lightweight one. And it's been around much longer than the Linux subsystem on Windows, and so it was and in fact, I mean, I'm fairly familiar with it because the software I work with professionally, the NASA software we're working on, also uses MinGW to run on Windows. ODG, yes. You said, remember, it wasn't one of the first real multitasking. That was one of its real benefits. It was multitasking, and for that, that was one of the reasons we were looking at it. It was a proper multitasking operating system. This Windows 3.1 was not. So. There's nothing wrong with MinGW, but it means that anything you sort of have this weird combination of Windows operating system services. You have Gnuplot, which thinks it's talking to Linux, and in fact what it's really doing is calling routines in MinGW, and then MinGW makes the appropriate Windows calls. And this stuff is hard. So the NASA software that I'm working with, we try to run under the Windows subsystem for Linux, or Linux subsystem for Windows. Why is it Windows subsystem for Linux when Linux really is the subsystem? I guess it's a Windows subsystem enabling Linux. Maybe that's why it's WSL.
That would be my argument. Is that the Windows created essentially it's a facade layer that allows Linux to talk to the Windows kernel as if it were a Linux kernel. Right.
So so obviously when WSL, the Windows subsystem for Linux, got along far enough, we tried to migrate. Our software to that from MinGW, and we're now at a point where we were at a point where we compile but not run. Then that was about 2 years ago. Starting about a year ago, it would compile and run, but it would not free up memory properly. So Linux thought memory was available, Windows thought it isn't, and that led to some really for software that's multi-process, multi-threaded with shared memory, using shared memory for inter-thread and inter-process communication. That is deadly. So we're still waiting for that to get fixed. Again, sort of long-winded, meandering detour. But so Gnuplot is running on Windows, but it really thinks it's running on Linux and is doing, and it's making Linux system calls that then get turned into Windows calls. So let me bring this thing up. Whoops. There we go. And here, there's another little menu I can use. Let's try this size. So
interesting. There's a comment in chat about Gnuplot not being particularly secure. I'm curious if they want to bring that up a little further.
Yeah, in Nordic, I'm curious what the See what? Oh, the website.
Oh, the website. That doesn't shock me. Sorry.
Yeah.
We should have cleared. I apologize. That makes perfect sense. Unfortunately.
Well, and you know, and of course that can be an issue if a website distributes software, right? So that's something certainly to keep in mind.
I say I'd say don't get me wrong. You're having a software distribution website be insecure is a major problem.
Mm-hmm.
Look at SolarWinds.
Yes.
Whoops.
Yeah, we so.
Supply chain issues are an issue everywhere.
Yeah, that's true. So there are some side effects of this. I'm guessing they couldn't be bothered to renew the certificate. ODG says, "Well, like I said, this project is active, which is good, and so it's not an abandoned project. You can see I'm running version 5.4, which is dated December 1st of last year, so about a month and a half old, which is not bad for open source software. And this is the stable branch. There's I think 5.5 is a development branch. So yeah, so that obviously is one of those issues that we have to deal with. If it is, so I mean, a distribution website that isn't super secure, obviously, is not a good thing. So I ran into a couple of things here. First of all, you might see this notation that the terminal type is Qt, and that really sort of refers to how Gnuplot is going to try to what graphics services it's going to attempt to use to draw. And so the minute you go from code that really doesn't interact with the user very much, or you go from scripts like Python scripts that can be basically be run on the same way on lots of operating systems. When you start touching graphic services of an operating system, each operating system has at least one or sometimes multiple options on how to do that. They change over time. Apple has changed their graphics environment, I'm going to say at least 3 or 4 times over the last 10 years. It was a quartz for a while, and it was graphite. I have no idea. I have no idea what they call the current one, but they've messed with their graphics environment. When macOS first came out, they used PDF. They used the PDF engine to do on-screen displays. Which is, when OS X first came out, it was actually a native Adobe engine. So there is a terminal type Windows, which remarkably enough is the default when you install on Windows. It also doesn't work. It's a known bug. You can't actually use that terminal type right now because something's broken. Right? And of course, heaven only knows, it may not be Gnuplot's fault. I mean, it's MinGW is not very well supported. It actually is not getting a lot of development. So it is perfectly possible that Windows changed something underneath MinGW, that one of the operating system service call translations are no longer working right. And so it took me a little while to figure that one out. Now, that said, Gnuplot is actually pretty cool, right? So I can do something. I'm going to mess this up from memory so badly trying to do this from memory, but you can do stuff like, let's see. I mean, it is pretty cool, right? And it pops a little graphics window that rescales, and so calls on Windows operating system services to create a window and a canvas, and create some tool icons. It has a weird zooming function. ODG says I'm sorry. Nordic is asking, Gnuplot like Mathematica. Not Mathematica and Mathematica. What's the other one? There's the one that the electro engineers use a lot.
What is the other one?
MATLAB.
MATLAB.
They all have graphing capabilities. Gnuplot has a whole bunch of built-in functions, so you can plot relatively complex mathematical functions, but it really is pretty much intended as a graphing environment, not a full mathematical modeling. It's kind of interesting too. So you zoom by drawing with the middle mouse button, then clicking with the left mouse button.
Oh, I remember that interaction with other places.
Yeah, so it's but a lot of that stuff's configurable. So anyway, so it does the job, right? It does the job. And I did manage to. I'll see if I can do this again. So one of the things that it can read data from a data file. And plot data from a data file, which is why I was looking at it in the first place. Now, I am going to find my cheat sheet, because I do not remember all this stuff. Actually, that one is not what I wanted. Let's go find it. Where's my... What did I do with my... There it is. Let's say. Actually, there is a documentation link here. But that's not what... That isn't actually all that helpful. Yeah, it is an HTTP website, yeah. It shows not secure there. I think the easiest thing to do is just to pop the... pop the help function. Let's see if I can find it here. So I know from my tinker around with it that the default, when you read a data file to Gnuplot, the default is a space-separated, white space-separated data file. So you have to set data file separator. So you have to go in here and modify that so they can read our data file. Now, this is probably the easiest place to see it. So our data file has a whole bunch of columns. I've gotten rid of some of them, but if you remember, the size is right here in column N. So this is the number of bytes in our video frames, and so let's try this. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is it 13 or 14? Oh, this is B. Okay. Well, minor details. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So I should be able to do something like this. And for reasons I'll talk about, I think it's original, right? Oh, I'm not in the right directory. Yeah, I can use CD, or I can. There's actually a helpful little way to do this. It's actually done not too bad. You can it'll basically do a CD command for you, which is kind of nice. I copied because I was having trouble with the CSV file we originally created, and I think I know what it was, but I copied that to another file and messed around with it a little bit. Not the content, just the formatting of it. So I'm going to do this, I think. I don't want the CSV. I created something called text. So and obviously I have to tell it what column of data I wanted to use. In this case, it is actually pretty smart. So if you specify a single column of data, it assumes it's a it's like a line or bar chart where it assumes evenly spaced data, and it just has basically Y data. So I think I can get away with doing something like this, and the one thing that I thought was really cool is it was super quick. I mean, this just took no time at all. And not that Excel takes a long time, but I mean, all the dragging and filling in the stuff. I mean, this is basically really, really quick. It's also not terribly useful because looking at it this way, it just isn't super useful. So let's kill you. For some reason, whenever I close the graphics window, it leaves a character in the buffer, and so everything I try after that, it gets messed up unless I hit enter a couple of times. So let's try this. I think this will work. So that is closer to what we were doing in Excel, right? So it's showing the number of bytes in each frame, so you can pretty much spot the iframes. In Nordic, yes, you can export there's a little, you probably won't be able to see it because there's really no way to enlarge it, and it's in the wrong place. It pops up in a different on my other monitor, but there's an let's see, you can export a PDF into SVG and to an image. You can also copy it to the clipboard. I know some of my colleagues in the scientific community have been using Gnuplot for a long time, and what they'll do, I mean, and I'm not going to go through all the decorations you can put on. I mean, obviously you can label properly. You can put units and labels and all sorts of things on the axes. They basically get a graph just right with Gnuplot, and then copy to the clipboard and paste it into a word processor when they were writing scientific papers. So yes, this can be exported to about 3 or 4 different formats, which is one of the nice things. That's sometimes a real headache. So I want to do a couple more things here. First of all, right now you can see well, you might not be able to, but I think I can fix that. So if you look at on the x-axis, this is actually the frame number because I only gave it the y y value, so it's basically just counting the number. So it's using the row number for x, which it happens to be the frame number. So that's actually not bad. If we want to convert this, convert this to time, let me go back to my Excel sheet here. The time for the frame is in here somewhere. I think it's this one here. Now let's pop up to the top. It's a bit easier to see. Yeah, so this is the actual frame time. So this would be 2, 3, 4, 5, 6, 7, 8, and this is 10, 11, 12, 13, 14. Yeah, so 10. So what I can do in Gnuplot, let's close this out. There we go. So what I can do is I can do this and give it another column as the x-axis. So now it should be in seconds, which, yeah, let me pop the magnifier up here. So now we go from 0 to roughly 2 minutes, which is right. All right, so one more thing, and then and I'll also mention why I ended up renaming the file. If I think I left everything in place so that I can actually show it. I may not be able to. We'll find out in just a second. This is where I needed my cheat sheet because I can't remember all the stuff I was going to do here. So if you recall, what we really wanted, because we're networking people, the data we're using is not random. This is something we did last week on stream. So this is a 2-minute video file. And what we did is we ran one of the components of the ffprobe package. And so what you're looking at here in the spreadsheet and what we've been plotting is the number of bytes in each frame in a video. It's 30 frames per second, 100 roughly 120 seconds, 120 odd seconds. So each row here is data describing one of the frames in the video. And what we were after is because of the way video is encoded, some of those frames take a lot more data to transmit than others, and we wanted to spot that. So that's the kind of the origin of this whole exercise. So it's not random data. This is actually a profile, a transmission profile of what it takes to transmit that particular video. So so what we did here is we actually calculated the transmission rate by converting from bytes to bits, dividing by the time per frame, and which is in one of the columns. I'll show that in a second, and then converting it to kilobits from bits per second. And in column L here, it's always the same. It wouldn't have to be. It depends on the codec. This one is running at a fixed 30 frames per second, so it's always 1/30th of a second. So what we did last week was to use Excel to compute this in a number of kilobits per second and then graph it. So to duplicate that in Gnuplot, what I need to do is, instead of just using I just realized I was using a different column. I think there's two different time. H and J. In this case, they're measured differently, and for our codec, they were the same. So this will work fine. So instead of doing the 10:14, which basically is X is in 10, Y is in 14, I've got to replace 14 with something. So we're going to replace There we go. I'm going to replace that with the same calculation we're doing. So we wanted to convert to, and now I've got to change to the, there's a dollar shorthand for the column numbers. So we want 8 times column 14, which is the size in bytes. So that gives us bits. We want to divide by column 12, and we want to divide by 1,000. So if I didn't screw this up, let's see what we get. All right, and so now we see we have a sort of a top rate of 160 megabits per second, and more of a sustained rate was at around the 60 megabits per second. Somewhere in here, and the sort of the anomaly down there. So I can't remember which. I think this was a very high quality video, not meant for streaming. This was a video that you would distribute to be played locally. But for the networking or load reason, definitely networking reasons. The reason we wanted to see this is while the average is all nice and good, as we put this away, as we run through this 2-minute video, there are clearly spikes, and so that determines things like how much buffering we need, how bursty the traffic is on the network, right? So this was a useful exercise from the perspective of and so just to close the loop. So where this all started, there is an age-old, talk about not secure. There's an age-old program called bitrate viewer that does just this. Problem is it hasn't been developed in like 10 years. The original website is gone. There's some third-party websites that claim to have executables of that software. When you try to install it, Microsoft says, "Do you want a program signed by unknown to make changes to your computer?" And my answer is no, I don't. So I was trying to find ways to conduct that same analysis, but not rely on something that insecure, right? So this does, with relatively little effort, as far as I'm concerned, right? I mean, you can weigh in, but I mean, this is not, once you, I can put this in a script, and kind of run this basically against each of the files that I create, and it would do the job pretty nicely. Just as a quick aside before we move on, I think is it here, yeah. So. Yeah, so interestingly enough, Gnuplot refused to read the file that I started with. And what I finally figured out, and I'm not entirely sure, but I'm pretty sure this is where the problem was. I think you can see that on screen, yeah. The encoding includes a byte order marker, thanks to pxlib for translating that for me, so I had no idea what BOM stood for. Apparently, Gnuplot does not read that. So I converted this. So this is the file that we were actually working with last week. So I made a copy, gave it TXT as the extension just so I wouldn't confuse myself, and just converted to UTF-8. And Gnuplot, obviously, as you saw, is perfectly happy with that. But the one with the BOM on it, not so much. The other frustrating thing is I tried to run this off of PowerShell, straight off the command line. No good. It will not read the data file no matter what format I tell it to use. I have no idea what's going wrong there, and I haven't had time to troubleshoot that yet. I've basically tried all the combinations I can think of, and didn't get very far. So that is Gnuplot, which I thought was kind of cool. I've always wanted to play with it. This was my excuse for doing so.
It's a perfect excuse.
Yeah. And so now that we get kind of into the workflow discussion that we wanted to have, because for me, working by myself, this is acceptable, right? So if I had, 4, 5, or 6, 10 videos that I needed to do this, I would write a little script to run ffprobe against each of them, generate my output files, and then pop in here, and I'd probably have a canned script that does the set data file separator, does a CD, runs the plot command, and I'll just have it basically pop the graphs for me, and then we talked about it exported to something that I can then paste into whatever report I'm writing or whatever I'm doing, right? So it's manual, but it works.
Right. It's ultimately what, half dozen, maybe 10 lines of shell script, and you can have something that would do most of this automatically.
And if I wasn't struggling with the fact that this isn't playing well with PowerShell, probably because of MinGW. So if I was if I did this on my Linux system, chances are I can just write it. It's a 10-line bash script that will just pop these things up, and then I can put them into my report. All right, so I'm perfectly happy with that, but that's of course not a general purpose solution, right? And Gnuplot, well, I really wanted an excuse to play with it, but you really have to want to learn it. I mean, God, this thing can do anything you want it to do. These plot commands can become very complex. Like I said, you can set axis titles and units and legends and plot titles, and you can define the fonts. I mean, the point of Gnuplot always was that it would let you generate graphs to the specification of a journal that you were trying to publish in. So you can create absolutely beautiful, perfectly formatted graphs out of Gnuplot. So it has a steep learning curve if you really want to plummets the depth of capabilities, but but once you do, and you basically can stuff in a shell script, it's not too hard. Right. So let me close this guy out. Clean up a little bit here. So Excel is kind of I think this is almost like driving a screw with a hammer, right? I mean, it's a very capable hammer, but it you really don't. But it would in theory work. But I would prefer the Gnuplot answer just because it's a bit more streamlined, but it is still a manual step-by-step process. All right, so now we get back into the issue of how do I now create a modern application. I mean, Gnuplot obviously is one of them, but I wouldn't call it modern if it started in 1986. And the way it's implemented clearly isn't terribly modern. So if we wanted to build something where a user would just take their video file, not the output from ffprobe, but took their video file and handed it to a program, said, "He got me the graph. I don't care," which is what bitrate viewer did when it was still alive. How would we recreate that? I mean, this is really where this discussion started, right? So how would we recreate that PXLib?
Right. I mean, well, obviously the answer to that is, well, how long do you have? Is it infinity? Because there's about that many ways we could do this.
Right. So just to kind of put a box around it, right? So we talked about using Python.
Yep.
Which is a very capable language. So our scripting gets very easy. We can kick off, but we need to tie in graphics because natively. I didn't want it that. I wanted this.
I actually want to roll that back even a little bit further.
Yeah.
Python. I would not normally point at Python as my language of choice for building something, right? It's just not what I work in at day to day. I'm comfortable enough to sort of bull my way through it eventually. Python is the right option here because Python is the de facto standard for modern languages when it comes to large data sets, right? The minute you start getting into machine learning or anything that's dealing with massive data sets, which if you're trying to map out an hour-long video, right, you're talking, I don't know, do whatever the math works out, hundreds of thousands of frames.
Yeah.
Right. which is very quickly going to get real messy. So Python was the sort of the obvious choice from that standpoint. But then, yeah, continuing that conversation, you obviously, you don't, Python's great, but we don't really want to draw a graph in your terminal. That seems less than helpful.
Right.
I've seen it done, but
yeah,
you know,
but not
an
what we
ASCII
want.
graph really not great.
That's not what we were looking for.
So digging around, looking for essentially a Python plotting library, and there's about 1 billion out there. Sort of settled on one that we've talked about a little bit, called Plotly, which not the most original name, but does what we want it to do. Does it in a way that's really useful. You can basically, they have a wrapper around the base plotting library called Dash, and they want to sell you their enterprise version, but it's open source, so we just pretend that we don't need that. And it will spin up a web server and host your plot, and you can add all sorts of inputs and outputs and update the whole thing on the fly, and it's very neat.
I think one of the key takeaways here is, and I'm assuming that's how this works, and so correct me if I'm wrong, but the problem again is I've got my data here. And that's why I'm using a different color. I've got my Python script here.
Mm-hmm.
And so Python is really good at reading and processing the data if that's what we want it to do. It'll do a really good job of that.
Fortran might technically be better.
Fortran would be better, but it's not.
I don't want to write Fortran either. As much as it was one of my first languages.
I made a living for 15 years writing Fortran. So yes,
my undergraduate thesis was in Fortran. So
yeah, it would be the best choice for this, but Python will do a perfectly admirable job of it. So the problem with the graphics is that I've got the same problem Gnuplot has. I've got to figure out some way to actually use the operating system to create a window with graphics in it. Mm-hmm. So what I'm hearing you say is that are we actually using a browser?
Yes. So this comes back to sort of conversations we've had a couple of times now, right? Browsers are a really great cross-platform way of rendering stuff, right? And that's what they do all day long. Render graphics, render text, render whatever you want. And now, so this sort of begged the question, and we talked about this a little bit off stream.
Yep.
Is it better to create something that's purely client side, right? That because right now this would be essentially client side, but in that it's all running on your local machine. It's not a server somewhere hosting the site.
Right.
But is it better to essentially just create a web page with some JavaScript? And that is an option. Plotly has a JavaScript library. There are other ones out there. I probably would lean on something called d3.js, just because it is the de facto JavaScript data visualization library. There we go. I got all that out.
So the code that the browser would see is something that would come out of Plotly.
Correct. Yeah. Or technically Dash, but Plotly is.
So Plotly would handle the graphics. Dash
is essentially the web server.
Dash would make sure that there's actually something for the browser to talk to.
Exactly.
Yeah.
Yeah, Dash is essentially, it's just if you know Python at all, you've probably run across Flask. Flask is a web framework.
Remember we did a stream very early on,
one of the first ones, I think.
One of the first streams we did, I spooled up a little Flask server. And I think this is one of the points I wanted to get to, is that, and I think this is a trend I've seen a lot. Because, like you said, browsers are so focused on presenting graphical information. They're super optimized to do that. Mm-hmm. And so a lot of times when you look at how to architect something like this, it's sort of natural to look at a browser saying, it can do all the drawing, and in fact, it has some fairly high-level primitives for drawing on a canvas in a browser. So the Plotly library probably wasn't all that complex to create, because the browsers already have some fairly decent primitives to create this stuff in the first place.
You can invoke and use It's still a little messy, but you can invoke and use three-dimensional graphics now. You can draw 3D canvases on in a browser. Now, is it going to be the most efficient thing on the planet?
Probably not. But as a as a cross-platform, ubiquitous,
that's the trick.
It's available, and so basically any user you're going to try to hand something like this to is almost guaranteed to have a browser at hand, right? So there's your that's fairly standardized. So if you're careful, shouldn't much matter which browser they're using, right?
To some degree or another, the browser wars of the 90s and early aughts are finally finished.
Yeah.
I did not pour one out for IE6 on its funeral about 10 years back. That was a good moment, good day.
Yeah, but so using a browser to host the canvas essentially is really not a bad idea. And so so in terms of deployment, and this kind of gets us to our final topic here fairly quickly. The concern I had is, again, I'm perfectly happy to I have Python installed anyway.
Right.
But obviously I need to have Dash and Plotly modules attached to Python.
Yep.
And this may be something we'll do for a future stream. So Python, I don't know if I don't know in chat if anyone's done any sort of Python development recently, and I started using Python years and years ago, and so I was kind of taken by surprise a little bit by these developments. But modern Python development pretty much assumes that you're going to create many separate and virtual environments for Python to run in, because otherwise you very quickly get into sort of a mess of having a couple of dozen modules of different versions, and they don't play nice together, and it gets ugly. So so you have to know a little bit about how to actually set Python up to do this. So it's a little better than my manual sequence of steps, right? Because once this is in place, all you do is basically open a video file and it spits out the graph, which is what we want. So I'd be very happy to see us build this, right? But that's why I was kind of wondering if hosting JavaScript on a browser on a like a static server, an S3 bucket or something, so that browser basically pulls JavaScript code and does all the work inside the browser. It's a hell of a lot less efficient. So there's a bit of a worry. I think we did this years ago, didn't we, for a different project. If you try to load, several 100,000 data points into a browser, it may not be very happy doing that.
Yeah, it gets real unhappy real fast.
Yeah. So that would be the downside, right? So if we try to do this in JavaScript straight in the browser, browsers are are really capable graphics engines, but they're not very efficient at managing large data sets.
Exactly. The issue wasn't actually the drawing. The graph itself that we created was relatively responsive. It was just the minute you were done dragging or trying to zoom in on it, it would sit there for about 5-10 seconds trying to reload,
because it had to
run through all the data.
It had to run through all the data, and we would run into this exact same problem here, whereas Python is going to be a hell of a lot faster at that.
Yeah, presumably. We'll find out.
Yeah, so I think to kind of leave this at this stage, I think I think one of the things that aside in sort of in parallel to LST, I suppose, one of the things we've been thinking about tinkering with, and this is something I can actually participate in. JavaScript leaves me baffled. I know ODG's been learning JavaScript in a hurry, building his OBS overlay.
It takes a certain degree of loose-brainedness.
ODG says that the problem is that a browser is basically an interpreter of interpreted languages, so a bit slow for anything heavy. That's exactly right. Yeah. Now Python is interpreted as well, but its interpreter is a lot more efficient at like numerical stuff, for example.
Yeah, and V8 and V8's the big one, obviously. Rhino, I think, is the JavaScript engine under Firefox. I'd have to double check that. Gecko, maybe. I don't remember. It's an animal name. But V8's the big one. That's the Chrome JavaScript renderer. It has gotten a lot faster. And then probably the right way to deal with, if you were trying to do this purely client side and dealing with, more than a few megabytes of data, you'd be starting to play with what's called WebAssembly modules. So WASM, because it's
I've
a terrible
seen that.
acronym.
Yeah.
So WASM is WebAssembly is essentially a number of compilation steps that you can take low-level languages. There's one for C or C++. I don't recall which one. I want to say C++, but more importantly, the way I have interacted with it on briefly is with Rust. So you can take Rust code.
Rust the language, not Rust the game.
Yes, sorry, I forget. Sometimes I forget where I had to clarify context. Yes, Rust is a very low-level language that's trying to usurp C and C++, Go and Rust. I think there might be a Go module for it. I haven't tried it yet. Bottom line, you can essentially pre-compile Rust code into something that is usable in a browser.
Oh, okay.
So it obviously is going to deal with things like large data sets and issues, manipulation of data much more efficiently than pure JavaScript.
Right. So it's not interpreted from the JavaScript level. It's pre-compiled basically, at least in the metacode of some sort.
Yes. Yeah. I've never pulled out the compilation. I've compiled some before. I've never dug it out to see if it's like, is it assembly level or a little higher than that?
I doubt it. I suspect it's be higher than that. Yeah.
As do
I. But nevertheless, that generally.
ODG asks, is it something akin to a DLL? Essentially, yes. So because it becomes more opaque to the end user, whereas JavaScript, right, is essentially I can, often it's minified and uglified, but that's a different conversation. I can, in theory, read any JavaScript on the internet, right, and figure out how it's doing what it's doing. A WebAssembly module is pre-compiled, so yes, I think a DLL is actually not a bad analogy. It's yes, exactly. That's what I'm trying to describe it as. Yeah, a DLL just as a precompiled library. Essentially that. But obviously, you have to write it all in Rust and C and some sort of a C-like language, and know the right invocations to call JavaScript methods from said language, and it takes real effort. But the gains are often worth it. Obviously, I have not gone down that road too deeply. Excuse me.
Okay. So I think the plan for us, because it's because of the class I'm teaching, there's actually some. So I've got. I'm not needed for the class necessarily because I can make the students go through the Gnuplot process that I just went through, so that'll work fine. But I think that sort of motivated me to sort of think through, what can we create that somewhat replaces the old bitrate viewer in a way that makes sense. And so I think we PXLip and I have sort of a not with any kind of timelines or deadlines, but we have some sense that we really would like to build this. By this I mean the Python base, Python code with Plotly and Dash, and so we have an entirely local system with Python doing the heavy lifting as far as getting the data in and processed, like pulling the numbers out of the columns and doing the computation. We just did in Gnuplot, which by the way is really, really fast. I mean, there was basically no delay in getting 3,500 4,000 frames dealt with. So it was really nice to see see it working that quickly. I think with 3,000 data points, a browser would do an incredible job, but you would see probably a little bit more of a delay of it coming up.
You'd see a minor delay depending on how complex your data manipulation is.
Exactly. But so I think I guess what I would say is stay tuned. At some point, I think we'll show off a Plotly Dash.
Yes. I think not too far off.
system to do this, which would be kind of fun. And then so this gets us kind of to our last topic. Then we obviously that's a development project to begin with, but then we'd also have to really really start thinking about how do you distribute that, how do you build an installer, so that this can actually work for someone who doesn't necessarily maybe have Python installed already, and so you want to. So one thing we talked about, are there ways to sort of encapsulate everything so that it can become not like a single executable, but at least sort of a single installation that kind of does its thing in a kind of self-contained way. And so those are things we're trying to work through as well. So we already, again, several streams ago had discussion Pierre Slip and I did over going through some of the common development methodologies, I guess is the right term. And so somewhat independent of this but triggered by this, and because of the project I'm working on professionally, the NASA software, and I think maybe I'll take part of a stream in the future to talk about that a little bit. But essentially, it's it's communication software for deep space communications. And one of the things that we, as in my research team at Ohio University, is tasked with is to maintain the repository of code and do regression testing. And we're struggling a little bit. We're using and I'll see if I can find the correct page here. We're using a platform called, if I could spell, called Redmine, which is in essence a project management. So this is actually let me enlarge this a bit. This is actually what you're looking at here is actually an instance of the Redmine system. And we have one running. I'm not going to bring it up because it does contain proprietary data, and I'm not sure. If I click the wrong place, I'll publish things I'm not supposed to. So I'm not going to bring it up. But this is the project. This is the software we're using right now, and so and this is pretty much what. What our instance looks like. It won't have ads. We won't have ads on ours.
Little things.
But we have a download page. There's an activity page, I think. We have issues, an issues tracker. And so this is a public project, so I'm not signed in, but I can see this stuff. Obviously, the instance we're running for NASA is locked down, so you have to sign in, register, and then sign in. The problem we're running into is there is a repository here, and you can browse the code and everything. The issue we're running into is that our developers, of course, access this repository through a command line. Right now, our repository structure is Mercurial, which is very similar to Git. It's a little older. Git has turned out to be much more popular, but Redmine does support some of the older repository structures and Mercurial and Git. But yes, our developers use a Mercurial command line access to get to the repository. It turns out that there's no automated way to set that access up. There's no mechanism. If I'm a developer who's signed into one of these projects, I can't get command line access to to a repository. So we have a bit of code that isn't part of the Redmine project. It's part of the community contributed code to the Redmine project that kind of does the job. But we've had to it has to be modified. It certainly wasn't designed for Git or Mercurial. It was designed for some of the older systems. It's been adapted for Git. It sort of works for Mercurial. We had to tweak it a little bit. And so we're looking for alternatives, and so Pierre Slip and I were talking about this and ended up with a system called GitLab, and this is actually an instance running on a computer in the next room over in my house. It's running on a virtual machine. And if you look at, it's relatively similar. So I just created a test repository, a test project here. So it has a sidebar instead of tabs across the top. But when I go to the repository here, one of the things that I noticed immediately when I looked at this is that it has the same interface as GitHub. So I can go in here, and I'm signed in as one of the users of this system. I can sign in, go to my project, and I can copy the correct URIs to access the repo directly with SSH or HTTP without any extra code needed. Let's see. Sorry, I did need to catch up on chat here. Yes, ODG said he found something called Video.js bitrate graph, and I did see that. And it is I think it is Python based. I don't know what
It's actually no. It's a pure JavaScript.
Is that JavaScript? Oh, it's Video.js. Yeah. That's right. That's a JavaScript one, right?
So this one, I was just glancing at it. It's an interesting one, and probably something if we wanted to write a pure client side again. So what this one does, I love the distraction. By the way, ODG's apologizing. No apologies.
Distractions are great. We love it. Absolutely fun.
What this one will do is take the HTML5 video tag, and you can basically have a video that's playing while a bitrate is being displayed. And presumably in graph form, it's probably really fancy and all that. Looks like it might be harvest is a pretty it's used by something else. Never mind. Doesn't matter. But that's my understanding. So we could probably pull it out and excuse me. I'm gonna. Nope. Yes, it's definitely interesting. I don't think in this case we actually need what they're pulling out, right? We already have the frame rate data. We already have the frame data coming out of ffprobe. Yeah. And we're using Plotly to create the graph. Thank you. Sorry about that. OG mentions it could be useful to check out what they're doing. But unfortunately, in this particular case, it's definitely interesting. But they're mostly just tying into actually another project, which is interesting, just for pulling out data. Actually, that's an interesting question. How are they pulling out something I'll have to look into. OG mentions thinking it might replace the ffprobe part.
Yeah, and I suppose it would. I remember looking at it. In my case, AJ, I think that's a little bit of a downside because ffprobe is super widely used, and the idea of using so I kind of like the idea of using ffprobe because it's a well-tested, well understood piece of software. There are some ambiguities about how to count these things, and I've followed some various forum threads that talk about why does ffprobe report this when this other tool reports this other number. ffprobe is pretty well respected for doing things mostly right. So there's that. So yes, I mean it's definitely something I did see that. I'd forgotten about it. It's something that obviously falls into this category of just basically a browser intrinsic and tied into HTML5. How it gets the frame data, I don't know.
Yeah, that's the part I'm really very curious about.
So
They get that.
lots of fun stuff to look at, which is interesting. So where was I here? Nope, I was here. So when I was looking at this, so this is the bit that I was kind of interested in because it will solve some of the problems we've had security-wise with the platform we're using. But then I kind of got into, what are some of the other options here? Because Redmine is a classic project management platform, right? But then I looked at this one, and it, obviously there are all the repository based bits of functionality, but then it does have an issues tracker. It has merge requests, which we talked about on stream a while back. That's when there's an independent developer and or a subgroup that finishes a job on a branch, and we have a merge request to bring things into the main branch. So I recognize some of these things, and I think that was that was kind of a let me think that maybe this is a more modern platform that sort of it aligns with DevOps kind of development stuff. So then I got to CI/CD and I've got lost. So maybe you can help. Maybe you can help fill in a bit about what I'm looking at here.
Sure.
Whoops.
Yeah. I should probably full screen you, huh? So I can actually sort of see. So I apologize. I zoned out there for a brief moment.
No,
My
no worries.
brain went somewhere else that likes to do that. So just to make sure, so I'm leading you in the right direction. You talked a little bit about sort of distributed version control systems. Git and Mercurial are the sort of the two most well known. There are some other ones. Why you want this sort of as an update to GitHub or update to Git. Excuse me, GitHub is a provider. You want to switch to Git. You want better authentication stuff, and GitLab provides the project tooling to introduce CI/CD pipelines. That's sort of
yes. So ODG's definition is correct. If I had Marvin in my chat, I would award channel points that I also don't have. So sorry, you didn't.
You actually got the first half. It's continuous deployment is the second.
That's right. It's deployment, not development, right?
Yeah.
So it's continuous integration, continuous deployment.
Yeah.
Is okay.
CI/CD sort of, and I'll be honest, I've never fully grokked why we have two different names for it. It's really just the same thing, right? It just points out that
you were close, ODG.
The software sort of nirvana state, and I'm stealing that from work. We came up with that term at some point because we've been chasing a
the
modern architecture. We've been chasing a modern architecture for our web applications for about 3 years now. That's a whole nother conversation. Is that I, as a developer, essentially am take it back a little bit of history, sort of, and ODG can probably speak to this a little bit too, because he probably dealt with folks like me. I, as a developer, historically have been distinctly uninterested in what I get. Yeah, I mean that's the strict definition, but they really blend together in this particular. Sorry, ODG mentions integration is getting all the different bits working together. Deployment is for all the different platforms you might be building it for.
Yeah.
Yes. Essentially, that is what it boils down to. They get very squishy in the middle there. Point being, developers like myself historically have not really cared where my code was going, right? I wrote code, it worked for me, I handed it off to some ops guy and they deployed it somewhere, right? That was essentially the process. And I would hand it off, and you've heard this one, Prof. It's, hey, it works for me.
Yes.
Right? Developers love that. That phrase is notorious for developers. It worked for me.
Yep.
I've used it before.
I've been on the receiving end of it because we do the testing, so we get some of the doors. But it worked for us.
Yeah. So conceptually, DevOps at a really high level, DevOps is this argument that, hey, what if we make the developers care about or knowledgeable about the ops side, the operations side, and not in the sense that, hey, we want them to go and learn Linux and spin up servers and harden them and understand firewalls, and right, that's not my expertise. But what if we sort of made it so that a developer can control the deployment, the operation of their own application? And so that's where this pipeline, the CI/CD pipeline concept sort of was born into. All it really means is that I, as a developer, when I'm writing code, obviously working locally, generally, another conversation, working locally on my machine, however my development environment is set up, right? Maybe I'm running a local server, web server, maybe I'm, Python, I have my Python environment set up, whatever.
Mm-hmm.
When I'm done and I think it works for me in my local environment, which tends to drift out of sync with the production environments, I push my code up to a central distributed version control system. GitLab, GitHub, Azure has one. Bitbucket is another one, right? There's a million.
That's where I started. That's where I started. Yeah.
Yeah, I would say it's where I started as well. Their pricing model was more useful many years back. Yeah. Now everybody's kind of about the same pricing model. So I've pushed my code up in sort of, again, historically that was the end of it, right? My code lived there. That was my essentially my official record. The DevOps approach says, hey, why do we stop there? Why do we split at that point from a development project to an ops project? Why can't it just continue? And so essentially there are just automated steps that can happen now.
Yeah, so ODG's saying, in his case, they used this. We had one code base during integration, split that out to deployable projects. So like the NASA software I'm working with, it's one code base. It has basic conditional compiles and some code that's kind of collected in what we call the platform,
right, and
platform code. So there's basic additional compiles to adapt it to Linux versus Mac OS versus Windows. Under MinGW, I should say.
For your application, that is more likely to be what happened, right? The build process. Okay, so we'll stop being high level for a second, and just say that as a DevOps developer, right, a modern developer, because that's in modern shops, I'm expected to have some interest in sort of the entire pipeline from my machine to production. And I think this is a good thing. And I'm going to address the ODG made another comment. I will get to that in a second because I think it's important to talk about. Yeah. In your case, right, the DevOps pipeline, the CI/CD pipeline would stop somewhere, right? So you would ideal world, and I'm going to jump into, so to get there, we're going to jump into one of the other topics too. So Git workflows are a really important part of a multi-developer project. It basically is just, here are the rules around what can be pushed when, or not when, but what can be pushed to what portion of the project. Because distributed version control systems, everybody has their own full copy of the code base, right? Unlike older ones where I would check out a file and I had full
and it's locked, and so I have control over it temporarily. Yeah.
Right. So if you're not a little bit careful, you end up with some really nasty merge conflicts, right? Where two people have been working in the same place on the same file for a long time, and they haven't been good about committing and merging, and all of a sudden you have 500 lines of file that the that the version control system has no idea how to merge, and you're in a bad place. So there's some responsibility on the developers now, and this is the first step of making developers more interested in and responsible for beyond just I wrote the code. So you've set essentially some rules, right? In GitHub, GitLab, GitLand on the internet, this revolves around, and we talked about this a little while ago, branching and pull requests. So if I'm working on feature X, right, it is my responsibility not to operate on the main branch, the core branch that is essentially your official code. It is my job to operate on a branch off of that where I can start stacking stuff on top of it, and eventually I'll merge it back in.
Right.
Now, if you do that right, and you're careful about, essentially it's called a rebase. You're careful about basically taking any changes that have been added to that main branch and bringing them over to your branch, just so you deal with merge conflicts earlier. It becomes a really straightforward process, because eventually down the road, I'm like, okay, feature X is done. I can merge feature/feature-X, it's my branch name, back into main. That is a Git workflow. It's a very basic one.
Right.
It's what we use because we only have about half a dozen developers.
And we use that, except that we for some historical reason we never use the main branch. We create and I'm not sure that I'm not a software lifecycle engineer, but we have integration branches for each major release, and so that becomes our temporary main for leading into a release.
That's not uncommon. That's distinctly not uncommon. That is, it sort of allows for a little bit of that historical, where normally I'd be working on I'd be working on release version 3.0, and that's sort of in its own thing. And eventually that modern, more, I don't want to say it's necessarily more modern. Companies that are more focused on being agile and deploying often don't tend to do feature or release branches, just because the goal is you have a pull request, you put on 3 or 4 commits, write a really tiny little feature, fix a bug, merge it back into your main branch, and that goes to production immediately.
Yeah, and just for way of context, because the software we're using, the software we're working on is targeted for basically space missions and those kinds of things. The lead time to get a new software load to International Space Station is like a year and a half. So they're running a release that we produced like over a year ago, and the release we just put out, actually the release we're going to put out at the end of this month, won't make it to the space station probably at best guess end of this year or early next year, right? So it makes more sense. So we basically create 3 or 4 major releases a year. So that's why that. Should we catch up on chat a little bit?
Yeah, I was just gonna say. So let me recollect my thoughts. I've been going a mile a minute for a little while. So going back to ODG made a couple of comments about turning a developer into an integration engineer. If you aren't careful, yes, I've had days. No, I say ODG he's just rambling. Ramble away. We love it.
Ramble away. We're just kind of finish one train of thought and we're jumping back, and so we're kind of scrolling back through chat and addressing what you were saying.
Yes and no. So to your statement around turning a developer into an integration engineer, and it's absolutely distinctly different skill sets, right? Like it is. I think a developer can learn to be an integration engineer. Sure, I have a friend who did it. They went and became essentially the ops side of DevOps. They deal with integrating all of the code that comes to them. Did it for some pretty big fintech companies. So he got big in that field. The trick to that is is what I was talking about, where if you deal with issues like that early, so if you merge, the rule is you commit early, you commit often, and you merge early, merge often. So you don't have, generally, I will admit to having failed at this miserably on 1 or 2 occasions and had 9-month-long branches. Don't do it. It's bad. Generally, it's a half dozen commits, maybe a few more, but over the course of a day, a week. before you merge it in. And that means you're only dealing with a day or two or a week's worth of changes, which means your potential conflict is minimized significantly.
Yeah, and so I think ODG's comment on merge issues with the integrate, because that's what we're facing, because we'll have developers who will basically work for 2 or 3 months, and then in the 3 weeks before the next release, we're trying to do all the merges. So that's much more. That's much more the experience that ODG had, I would imagine, where you have a massive merge that could generate issues where multiple teams have to go back and rework their respective code, their respective code to make it mergeable. We've definitely run into that.
Yeah, and so you a good Git workflow and I'm going to address, because that is agile with a capital A, I imagine, on a modern agile software development team, just essentially short circuits that issue by not allowing development to go on for too long. Eventually you get a scrum master or a product owner who looks at a developer and goes, why is this feature not released? What's wrong? Why is it going on for so long?
Yeah.
Deal with it. Or at the very least, you have a good developer who says, oh, well, no, I've rebased multiple times. I've dealt with any merges before this issue happens. And but the other thing is that puts the responsibility back on the developer to not try to merge stuff into the main branch before it succeeds. The other caveat is, and this is where we finally get back to pipelines. I knew we'd get back there eventually. A good Git workflow integrates into a DevOps pipeline by allowing, essentially, again, we're going to go back to this Nirvana state. In my Nirvana state, you have a branching workflow, right? A Git branching workflow where I, as a developer, pull an issue off of our backlog and say, I'm going to work on this over the next couple of days. I create a branch that's properly named. I start working on it. I commit early, I commit often, I push to the central version, the central repository as often as I think about it. And just so you know, it's just for storage. But what happens next is the important part. When I push code to that pull request or to that branch, a good DevOps pipeline will fire off immediately. And it will start doing things like running tests.
Yeah, and ODG, that's where your comment about testing comes in. And one of the things we do in my group is when the developers are done with the merge, and so we're doing what PX Lip is describing, was doing it manually. When our developers are done with claim they're done with the merge, we kick off that pipeline and go to a number of different platforms and run standardized tests, run regression tests to find problems.
Right.
So what you're talking about is having that happen automatically when things get merged in. Yeah.
But not even when they get merged in. The minute I start writing code. So
okay. So even in your branch before, not in main.
A good Git workflow introduces a rule that says if your pull request branch fails tests, you cannot merge it.
Okay.
That is a hard and fast rule. And so from there, you get all sorts of other things you can say about it, right? You can say, does your code style match our defined style guide? No, you can't merge. Have you written? Do you have code coverage? Right? There are all sorts of code coverage tools that say, hey, you've written new code that isn't properly tested. Write a test before you can merge it. Has your code been reviewed by another developer? You can set. So these are all sort of
interesting
prerequisites you can set that say before you can even consider merging this into your main branch, these steps must be taken.
Okay.
And so that is where DevOps really starts shining, because it sort of nips issues like what ODG is describing, where you have integration issues, right, in the bud, right? It says I cannot merge until every test passes. Every test that we require to passes, right? How often does a full software development library, except for when it's going to the space station, different conversation, how often does a software product pass every single test you write for it, right? There's usually something that's failing weirdly. But it must pass whatever tests are required. It must have been reviewed by another developer on the team. It must be properly formatted, and you must have written tests that cover 95% of code, right? Whatever your rules are. And there are all sorts of other things you can do, right? Any automated system can be integrated into these, right? You want a Slack notification that goes out that says, hey, new pull request, do you approve? And someone has to type approve in Slack. You can do that, right? And I don't know why you'd necessarily do that, but you could. But that's where it cuts it off.
I think this GitLab, by the way, does have Slack integration, Microsoft Teams integration, yep. Discord integration through webhooks.
Well, and yes, it absolutely does. All of these do, and webhooks basically mean you can do anything. I'm going to respond to ODG with big projects. Dev won't commit to the main branch, but a Teams integration branch. And I'm going to say that's not entirely true anymore. They won't even commit to a team integration branch. They commit to a personal. They can commit to a personal branch, right? A small. And I mean, Google is doing this. Facebook is doing this. I don't know about other, obviously different companies do things different ways. I can speak to that. My organization is still learning the modern ways. Let me put it that way. I'm trying to lead them into the light. But with a properly done, even with a big project, if you separate out, you're dealing with a single branch, and that really removes the sheer number of dangers of integration, right? Because you deal with small slices because you deal with small slices of code at any given time, your odds of breaking the whole thing with a merge become much significantly smaller. So let's roll it a little bit back now to we were talking about this sort of plotting application we want to build and how that might integrate, or how your application might integrate. Sorry, I have a cat who's going to come join me. So in those examples, right, you're thinking about so let's reset my brain a little bit.
Chasing the cat.
Yeah, cats. What can you do? So say we've passed all of our tests. Pull request is good to go. I've hit the merge button, or I've committed the merge, whatever. What happens next, right? Typically, there's another pipeline that will fire.
That's where this comes from. Okay.
Yeah. So the reason you have multiple pipelines, right? You can have a pipeline for branches, right? Pull request branches, and then you have your main pipeline, and that tends to be I'm going to deploy to either, depending on what your levels are. I'm going to deploy my code to staging, wherever that might be, if we're dealing with a web or some sort of a hosted application, or in a really modern, and I still need to come back to that word, agile environment. It goes straight to production, right? Because your pull request branch passed all the tests, it's been sniff tested, it's been reviewed, all of that. It goes straight to prod, and the pipeline is what does that. Now, in the case of your application, right, what that probably means is you fire off 5 or 6. I don't remember how many combinations you said you have. 5 or 6 different Docker environments hosted on 3 or 4 different servers, because you need because you need different OSs,
different operating systems, and different configurations, 32-bit, 64-bit.
Exactly. And so what will happen is your pipeline will fire off however many of those you want, using Docker or some other engine, and it will use it to build artifacts, your binaries, and then it'll collect up those binaries and attach them to a release, and boom, you have your nightlies, right, or your current edge release of your application that somebody could then download.
Right,
and then you can do things with tagging.
Just as a sidebar, as we mentioned OS2 earlier as one of the oldies but goodies, maybe not so goodies in that case. The oldest environment we test on, because NASA still runs these in the Deep Space Network, we have to test on not only on Solaris, but Solaris running on a Spark processor.
That's right. You mentioned that before.
And some of the Deep Space Network ground stations use old Spark hardware Spark-based Sun microsystem hardware, and so we still have to test on that. Which is a real pain. We have the fastest Sun microsystem Spark-based architecture server in our rack that that you can find on eBay, and it's still mighty slow compared to a Mac Mini. Anyway, so sorry. Move.
No, please. That was
ODJ, you're not the only one who sidetracks conversations.
Right. It's great. I love the sidetracks. No, so that's one example, right? Your application will probably build some binaries, collect them, attach them to the repository, and someone can come and find it and download them.
Yeah.
Not entirely true. You probably will have to push them up to whatever your central repository is, because you have all the request processing.
Yeah.
For something like this plotting application, that's fun. We'll come back to that in a minute. For something like this plotting application, right? We had talked about, because we could probably compile it together into a binary. It would be really tricky, not worth it. What's probably better is to, obviously you can grab the source code, install the requirements yourself. Some people would choose to do that, but why not do it in a Docker container? And so
that's an interesting idea. Yeah.
A build pipeline will happily build a Docker container, and all I'd have to do is Docker run with whatever arguments I want, basically pass it a specific file so that it mounts the volume, and away it will spit out a little web server that I can play around with the data on it, right?
Yeah.
Straightforward.
Yeah, and in fact, I'd totally forgotten we talked about that. I think that's what we're gonna work towards.
I think that's my end goal.
I think the end point of our pipeline for that is going to be a Docker container.
Yeah, if we can pull it up, I think it's totally doable. It'd be fun. But
that should be doable. It should be doable because I can deploy Python with modules.
Yeah,
I can mount. But it's just conceptually that should work.
It is relatively straightforward. It's just have to make sure we get it right.
Mm-hmm.
And then right, then you go sort of to modern production web applications, which tend to actually be very similar. It tends to be build a Docker file, build the Docker application, and push it to some sort of a registry, and then whatever your container orchestration system is gets webhooked, and fires off a webhook, and your orchestration system says, okay, I'm about to start spooling down old ones and spooling up new ones to make sure that we're still matching your scale. Straightforward, zero downtime deployments. I say straightforward. Kubernetes is far from straightforward, but
yeah. So you want to Y2K testing? Yes, I did some of that for in my previous life. Yeah,
I say I can make you both feel old. That was far before my time.
Yeah, I was involved in some Y2K testing, not in my previous job. That ended in '91, but with my previous NASA project is what I meant. It's getting late. That was, I don't even remember what hardware it ran on, but it was as old as the hills. And it did have not a Y2K problem. We actually it had a related problem that actually manifested a little, very, very, very close to the same time frame. It was kind of a Unix rollover problem. The problem was because that project was started the spacecraft launched in 1993. The software was written in like 1984 or something like that. None of the developers were around. This is basically frozen in time code, and no developers. And we knew it was going to fail in like a month. I actually dug through the bloody C code and patched it. I am not a C programmer, but I was the only one around who could. And that patch ran. My patch was in there until the end of that project, until the spacecraft was shut down. So, yeah, it was Y2K related. It was the date manipulation was a little bit different, and they had arbitrarily picked a date sometime in like the late 70s as the base for counting dates, and so we were running out of space in a variable like about a year after Y2K. So some of the dates tested are still in the future. Yeah, no, and trying to future-proof something
are we coming
that
up
old.
On? Are we coming up on an issue? Isn't the Unix epoch, the
yes.
32-bit Unix epoch coming up?
Yeah, I think that is coming up. Yeah, we'll have to do a little bit of research on that. ODG, that'll be a fun topic for your stream, is to track down the Unix epoch issue, because that's a Y2K it's kind of a Y2K similar issue that's going to come up again for some systems, not for all of them, but for some systems. All right. Contrary to what I said, we actually ran almost 2 hours today, so I think it was a good discussion. No, and then this was fun, and we haven't even dug into GitLab very much, but I think what we're going to do is maybe not with GitLab, because what we're doing will live just fine on GitHub, although GitHub may not have all the tools we want. So we'll have to kind of think about how we're going to do this.
Yeah, we'll have to talk through it. I mean, it has
does it have pipelines? Okay.
Yeah, they call it actions.
Okay, because what I would like to do, because this Odishi says he can't remember all the affected dates and all the reasons, but it was interesting to do it. That's it. In some ways, those things are fun, right? Because they're pretty defined. You know what you're trying to do, and yet it's just one of those. Why on earth did we get ourselves into this mess? So I think what I'm going to suggest, if you think this is doable, and we'll kind of spatter this in over the next few weeks and months as we play with this. And this isn't fortunately not a hugely large project. What I'm thinking is maybe we'll try to build this Python-Plotly based system, and try to do it in an agile DevOps environment where we actually use GitHub and use pipelining and do sort of continuous deployment, sort of figure and deploy to a container.
Yeah.
I think that
to container and then deploy it to the Docker registry.
Right.
So that's the 2 steps there.
Yep. And so I think that project is pretty nicely self-contained. It shouldn't be super difficult, but it just has enough interesting stuff going on that I think it would make sense to play around with that.
Yeah.
So that's going to be the plan, and so that'll be a way for us to kind of revisit Agile and CI/CD and pipelines and those sorts of things, but do it was really super concrete examples. Right, so hopefully that'll be an interesting. I mean, it's certainly. I know it's going to be interesting for me because I've never done this before. I mean, that's not how I've developed software when I was a developer. But it is neat. I've taught about the project management aspect of it, but I've never been involved in an actual, actually practicing, working through the actual process of implementing this and with all the automation. I'm not sure we're going to deploy Kubernetes, but it's we'll do that in a different context. But this is so that's going to be kind of the plan going forward. That we'll actually develop this, and probably what we'll do is take some early version of the project that does something useful. Maybe it's not going to do all the graphing yet, but it's going to run the ffprobe stuff and do something sort of kind of useful with it, and start building the pipeline so we can kind of talk about that as we go. So with that, I think we're going to wrap it up here. I see that I think Resurrection Fern is on. At least I thought I saw her a little while ago. And she dropped off. The Twitch is so weird sometimes. No, oh man, what happened? She must have gotten a huge raid. She's
oh wow.
She's got like 700 odd viewers. That's cool. All right. Nevertheless, I think Thank you for those that were hanging out here. If you're watching on the VODs, jump on my main channel, and if you're on Twitch, please hit the follow button. If you watch this as a YouTube video, please hit the subscribe button, and then go over to Twitch and hit the follow button. I'd love to have you join us in future streams. What we typically do, if we have an opportunity to do so, we jump over to Resurrection Fern's channel. She's a delightful singer-songwriter, and it's kind of a nice place to wind down the evening and listen to some good music. So that's what we're going to do now. So again, thanks everyone for being with us. I'm going to get a raid started, hopefully, Twitch permitting, and we'll see you next week. ODG, thanks for being here again. Appreciate it.